Good morning, everyone. Welcome, and thank you so much for spending part of your day with us. My name is Kara, and I'm with the Ohio LTAP Center here at ODOT. I'll be your host for this morning's session. We have a fantastic presentation lined up for you titled Multimodal Training Series Guide, focused on curb ramp design and multimodal design guide. We are thrilled to have Miriam and Jeremy here with us as our expert presenters. Before I hand things over, let's go over a few quick housekeeping items so we can make the most of our time together. For your questions, please use the questions panel on your screen at any time during the presentation. Type them as they come to mind, and we'll round them up, and then we will ask them at the end of each section. For technical issues that you may run into, any audio or visual glitches, drop us a line in the questions panel, and our team is monitoring that, and we'll do our best to get that sorted out for you. Materials. If you want to follow along or take notes, you can find a PDF of today's slides right now in the handouts pane. We are recording today's session. You'll receive an email with a link to the recording and a PDF of the slides within the next 10 business days. Certificates, some of you I'm sure are interested in. So if you are logged in and hanging out with us for the full duration of the webinar, your certificate of attendance will arrive in your inbox within 5 business days. And we will be taking a break about halfway through the presentation. I know sometimes that's on the top of mind when we're getting ready to start a wonderful, engaging presentation. All right, so that's it for the logistics. Let's get to the good stuff. Jeremy, I'm delighted to pass the virtual microphone over to you. Take it away.
All right, thanks a lot. Yeah, welcome everybody to ODOT's Multimodal Design Guide training series. We've been giving lots of in-person and virtual training since the release of the Multimodal Design Guide. And one thing we know is that people have a lot of questions when it comes to pedestrian accessibility, not just since the release of the Multimodal Design Guide, but also the release of the US Access Board's PROWAG, and trying to grapple with what this means when it comes to the design and implementation of our project. So I just want to thank ODOT for putting this series together, and we're looking forward to digging into the details today. So I'm Jeremy Chrzan. I lead Toole Design's multimodal design practice. I'm based in Silver Spring, Maryland, but have the privilege of doing work all over the country and seeing what people are doing, and also was the project manager for ODOT's Multimodal Design Guide. And then I'm joined with Miriam, and I'll let her introduce herself.
Hi, good morning, everyone. My name is Mariam Massoud. I'm an engineer at Toole Design, and I sit in our Columbus office. I've been here about 5 years, and I also had the pleasure of working on the Multimodal Design Guide.
So today we're going to go through quite a lot of content. We've got a lot of time though, so no issues with that. And we have plenty of time for questions throughout. So as was said, please put your questions in the questions box and we'll get to those throughout the presentation. So today, this is the quick summary of what we'll be going through. We will start with a quick history of the ADA, get into some of the scoping and sort of administrative things around accessible implementation and design. And then we'll get into the technical details, the curb ramps themselves, the different types, the slope requirements, how that relates to quick build and temporary installations during construction, as well as some of the signalization pieces, since the accessibility of push buttons is so tied to the placement and design of curb ramps. Then we'll go through some actual design projects and sort of walk through some of the implementation challenges and options that we have as practitioners, and talk about some of the pros and cons and how you make some of that, how some of that decision making happens. And then at the end, we'll have a bunch of photos of some good, some bad implementation, and see if we can put into practice what we've learned during today's workshop, and identify what is and is not compliant with those specific examples. So with that, we'll jump straight in. So the history of the ADA is very much a long history, and it predates the ADA itself, or the Americans with Disabilities Act. It goes all the way back to the 1950s, when you had people like Hugo Defner, who was an activist campaigning for accessible architectural design, and he was invited by Dwight D. Eisenhower when he was president to come to Washington and receive the 1957 Handicapped Man of the Year award. He was an insurance salesman, and he really was pushing for wheelchair accessibility in both public and private buildings, writing letters to the president and various legislators to really highlight the importance of making buildings and facilities accessible. And I don't think he could have proved his point better when he arrived to receive his award. And he had to actually be carried into the auditorium by a pair of Marines, because this is the building where the award ceremony was being, where it was occurring. And so that really disturbed President Eisenhower. And so as a result, they immediately looked at how to address architectural barriers in their meeting later that year, and really started to get the ball rolling at the federal level. So since the 1960s, there have been a variety of different design guidance and standards that have been implemented. The National Standards Institute, they had their release that talked about accessible building and facilities design, and that's really the first nationally recognized accessible design guide. But then we also had the civil rights movement that was occurring in the 1960s. And so the disability community really latched onto the civil rights movement, because fundamentally that's what accessible design is all about. It's about not discriminating against people who have a disability and helping to ensure that they can go about life just like somebody who does not have a disability, without any additional needs, like a Marine carrying you into a building. So then we had the Architectural Barriers Act. That was the first federal law to address accessibility, and that required that that facilities be designed, if they're designed, built, and altered or leased with federal funds, that they needed to be accessible. And that was passed by Congress and sort of set the stage for accessible design moving forward. But again, that was 58 years ago that some of these design guidance documents were released. The Rehabilitation Act, again, was another one of those things in '73. It prohibited employers and organizations from excluding or denying opportunities to people with disabilities. And that was also what formed the Architectural and Transportation Barriers Compliance Board, which ultimately became the U.S. Access Board as we know it today. The Architectural Barriers Act really only applied to federal buildings, and many things in public life were simply not covered by the Rehabilitation Act. So telecommunications, many forms of transportation, healthcare providers, et cetera, were not covered by the Rehabilitations Act, because they either didn't receive federal funds or were exempt as a small provider. So more guidance needed to be provided to ensure that facilities were going to be accessible to people with disabilities. And ultimately, that led to the signing in 1990 by George Bush of the Americans with Disabilities Act. Again, that was 36 years ago. But that said, all public facilities, not just those that were receiving federal funding, needed to meet the needs of people with disabilities. And little did George Bush know that later on in his life, he would benefit from the passage of that legislation when he was wheelchair bound and needed some of these facilities in order to be able to navigate the built environment. So what did the ADA actually say? It said that it was to provide a clear and comprehensive national mandate for the elimination of discrimination against individuals with disabilities and provide clear, strong, consistent, enforceable standards addressing discrimination against individuals with disabilities. So as I said, this is linked to the civil rights movement. This is really about eliminating discrimination. So again, this is sort of that walking up to the adoption of the Americans with Disabilities Act in the 1990s. And then we had the creation of the Americans with Disabilities Act accessibility guidelines. Those were developed in the 90s and early 2000s. Sometimes you'll hear that referred to as ADAG. And ADAG is really focused on building design, though it did have some guidance on things like curb ramps for within parking lots. But what we ultimately needed was accessible design guidance for the built street environment, because streets are so unique and are the main transportation hub of our country. And so how do people use that transportation facility in an accessible way to navigate that built environment? So the development of PROWAG happened over a long period of time. It's actually 30 years that it took to develop that guidance, but ultimately that was adopted in 2023. Any questions on sort of that upfront history before we jump into scoping? Don't see any in the questions bot, but again, if you have questions, please put that in the questions chat, or not chat feature, the questions box.
Thank you, Jeremy, for pausing and asking if there are any questions. We do not have any questions so far.
Okay. Well, jumping into scoping requirements. So ODOT does have a policy on this, 21-003P, which says that compliant curb ramps shall be constructed at intersections located within the limits of resurfacing for all your resurfacing projects. And that's regardless of whether it's an urban or rural location. And that occurs whenever we have curbs or sidewalks that are present. And if there are curb ramps that already exist, we have to assess whether those curb ramps are already compliant or whether they need to be upgraded as part of that resurfacing project. So when we are constructing a curb ramp on one side of a street, that also means that a companion curb ramp or curb cut is required on the opposite side of the street. Essentially, if you have a curb ramp and begin a crossing, you need to be able to complete that crossing. And where resurfacing extends into the side streets and impacts curb ramps that are located there, those curb ramps also must be compliant. So what does that look like in practice? If we look at the example on the left, where we have an intersection with sidewalks and curb ramps that are existing in that location, if a resurfacing project were coming through here, that would trigger the need to evaluate those curb ramps, and if they are non-compliant, to then replace them. By comparison, the example on the right side, a street that it's a T intersection that has no existing sidewalks that are present and no curb lines that are present either. That if a resurfacing project were going through there, that would not trigger the need for the installation of curb ramps. The policy also says that a break in a curb needs to be constructed to provide a person with disabilities at all intersections, that you need to provide a break in that curb if there is a curb line, even if there isn't a sidewalk that's present. And if we are doing this, then the existing curb has to be cut flush with the pavement for a width of at least 5 feet, and then you taper the sides of that at a 3-to-1 or flatter. Um, and what that looks like, and we have an image of this in the ODOT Multimodal Design Guide, is it's a curb depression with grading that's sort of similar to a concrete curb ramp, but just graded in the adjacent soil material to allow somebody to get beyond the curb and behind the curb, or from behind the curb and into the street. So in the example on the left, you can see that's a intersection that does have curbs along the intersecting corners. And so if a resurfacing project were coming through here, it would require these curb depressions to ensure that that pedestrian could navigate across that curb line. In terms of how the cost of curb ramps are absorbed by projects, ODOT's policy reflects on that as well and notes that the cost of curb ramps that are outside of a city or village need to be funded as part of the project. The cost of a curb ramp inside cities within the limits of resurfacing project need to be funded by that local agencies. And cities need to measure any existing curb ramps that are within their project limits or resurfacing limits and ensure that they're providing ODOT's district with a certification of ADA compliance before their first plan submittal. And that's also where we would document if compliance is not technically feasible, the need to submit a waiver to document that you've done your due diligence and tried everything that you can, and simply can't create a fully compliant design. This question of companion ramps comes up a lot, I assure you. And so essentially it just says that a crossing of a street consists of the crosswalk itself as well as the curb ramps or curb depressions on either side. And so if we're installing a curb ramp on one side and can get into the street, that means that we need to have that companion ramp on the receiving side. So new curb ramps being constructed at a crossing, we need to evaluate both sides of that crossing and ensure that both of those locations will be compliant. If they're not compliant in the existing condition, then that triggers the need for those upgrades. Another thing to consider in this is when you're doing resurfacing and it triggers the need for a companion ramp, that may require us to slightly alter our project limits to ensure that that companion ramp can be included as part of the design. And it's important to evaluate that sort of early in the project so that you are establishing a project limit that reflects the work that will need to be done in order to meet this accessibility requirement. And so that would require us to look at the curb ramp as well as any minimal sidewalk work in order to make those connections accessible. So just a quick illustration. So we're all talking the same thing. Here we have a clearly marked crosswalk of a roadway. And so those curb ramps on either side of that, whether it's a sidewalk or a shared use path, those curb ramps are all part of the accessible route in order to cross the street. So curb ramp, crosswalk, curb ramp, part of one accessible crossing of the street. Any questions when it comes to scoping?
So thank you for asking, Jeremy. There was a question, and I asked to get some clarification on that. So I'm waiting for clarification from Christine on her question. The other question that has come in so far is, what if one corner had a sidewalk without a compliant curb ramp, but there was not a sidewalk on the opposite side of the street?
Mm-hmm. So that would fall into the, well, I guess you would have two different considerations here. If there is a curb on the opposite side of the street, but no sidewalk, that would trigger the need for the curb depression. If there is a sidewalk on the receiving side of the street and no curb ramp, then that would trigger the need for a curb ramp that also connects to that sidewalk.
Wonderful, thank you. Okay, um, Christine has clarified her question a little bit. She says, please expand on the requirement where surfing extends to the side street and impacts the curb ramps located there. Those ramps shall be made compliant.
It's if the resurfacing extends into the side streets, which is fairly common with some projects, that you're not just milling and overlaying through the intersection flush with the curb line. You might be wrapping that around the corners, and so that mill and overlay may extend across that. Um, there are also some times where there is an existing diagonal curb ramp and you're trying to replace that with two separate curb ramps, and we'll get into that in the technical details a little bit later. But sometimes when you're splitting those ramps into two separate locations, that also triggers the need for creating a little bit more mill and overlay so that that connection can be made accessible. Does that help to answer your
I think
question?
yeah. So so if this resurfacing doesn't wrap around the corner, do all the ramps need to be rebuilt?
If the mill and overlay is just sort of parallel with the curb lines of your roadway and you're not touching an existing ramp that might be along that radius to cross the side streets, you're not milling and overlaying in front of that ramp, and you're not disturbing that ramp to construct your ramp to cross the main street, then that would not trigger an upgrade for that side streets curb ramp.
Aha. Okay. Next question. You guys got a lot of questions on this, just this first part. Your next question. What if you have a curb ramp that's on the other side of the widening with no resurfacing? Does the curb ramp have to be fixed?
I think what you're saying is you are milling and overlaying adjacent to, we'll call it the departure ramp, but maybe you're only milling and overlaying to the center line of the roadway. That still triggers the need to evaluate the receiving ramp to ensure that the crossing itself is fully compliant. And this is something that the Access Board has weighed in on, as well as the Department of Justice, that they've identified that mill and overlay is a trigger. And then, as I said, the crossing itself consists of the curb ramps on either side and the crosswalk. And so if we are altering any one piece of that, the whole crossing needs to be compliant.
Aha.
So
Okay.
if your mill and overlay only extended to the center line of the road, then you would essentially have two options. One, extend that mill and overlay a little bit further to encapsulate the receiving curb ramp, or leave the mill and overlay where it is, but you will still end up disturbing that receiving corner. You'll probably still have some pavement disturbance in order to construct the curb ramp itself. So it would sort of be dependent on the project that you're doing and whether your mill and overlay limits are locked in or they can be slightly adjusted to encapsulate that entirety of the crossing.
Uh-huh. Okay. Thank you for that. Next question.
Mhm.
Does a developer or property owner that does repair to the walk or ramp in front of their project have to comply with a companion ramp?
It's my understanding that any alteration constitutes a disturbance of the accessible route and requires that evaluation of the accessibility of the whole crossing. And I've worked on many developer or reviewed many developer projects where this sort of comes into play, where you are disturbing one corner of the intersection, but it requires you to evaluate the crossings that extend from your corner to the adjacent corners. What tends to get confusing is then if you are then disturbing the receiving ramps on the opposite corners, how is that affecting the crossing of the other legs? And this is where it is a case by case basis based on the conditions that you encounter within that intersection. So there are times where by disturbing one curb ramp, you are then slightly altering the crossing of another leg of the intersection, which requires you to sort of chase your tail around the intersection. Doesn't happen every time, but it is sort of contingent on the conditions that you encounter.
That absolutely makes sense. Thank you, Jeremy. Okay, we have one more question, and then you guys can move on to your next section. um, let's see here. Alex asked if you've witnessed any major right-of-way issues on corner properties in order to make the ramps compliant that might require regrading.
Yeah, and the issue of right of way is sort of tied to the scope of your project. So when PROWAG was released, in the case of alteration projects, the previous drafts included right of way as a physical constraint that could be used as justification for providing a um, for documenting technical infeasibility and providing a ramp that doesn't fully meet the requirements of PROAG. In the published version, they removed right-of-way as a physical constraint. And so if your project is already doing right-of-way acquisition as part of the scope of the project, even if it's not at that specific location, then it needs to be evaluated whether right-of-way needs to be acquired at that corner. If right-of-way acquisition is not part of the project, then the right-of-way lines are then the constraints and requires us to still be creative about how we can provide either a compliant or as compliant as possible for that curb ramp construction. And so that does typically require some grading or the creative use of things like curbs along the back, sometimes referred to as cheek walls, just sort of serve as a kind of a mini retaining wall that limits our impacts of grading. All of those are tools in our toolbox. I've also had projects, though not in Ohio, where I simply have approached the property owner, identified that some minor grading within their property is needed in order to construct a fully compliant curb ramp. Would they be willing to sign this letter format, allowing me to disturb a little bit in their property and reseed it and return it to a condition similar to its existing condition? And I've had some good success with that, simply explaining that by allowing us to do this, that this helps to ensure that the design would meet the needs of people with disabilities and align with the Americans with Disabilities Act. If they don't want to allow that, or to provide a actual construction easement, then that's their prerogative. It's part, it's again tied to the scope of the project.
Oh, wow, that's incredible. Okay, so we had two more questions come in while you were talking.
We have time
I will
for questions.
ask you, would you rather answer the questions now, or would you like to go ahead and move on with the presentation and we'll come back to them at your next pause?
Well, why don't we limit it to the two that have come in, and any additional ones that come in, we'll hold those till later.
That sounds wonderful. Okay, so Dave says that ODOT's policy is written in terms of resurfacings, but the policy applies to all projects, correct? As in like replacements and things like that.
Yeah, I mean, it's mentioning resurfacing because there are lots of questions around
Mhm.
what is a trigger for meeting for making some of these upgrades or doing the evaluation to identify if you need to make the upgrade. If you are doing a physical reconstruction project, all of this definitely holds true. Again, it's tied to, is it altering the crossing? And the big question has long been, is simply milling and overlaying the road an alteration? And that's the thing that the Access Board, the Department of Justice, and then ODOT's policy are reflecting.
Aha, wonderful. Okay, last question is promised for this section. Uh, Matthew asked, could you share a little about the waiver process? Are there any requirements or guidelines for what constitutes an acceptable or unacceptable situation for a waiver?
Miriam has a little more experience working on ODOT projects and actually completing these waivers, so I might ask her to chime in on this one.
Thanks.
And I might punt it to later in the presentation. We have a section on that with some slides. So trust that it is coming later.
Wonderful. All right. So, Matthew, if your question does not get answered later on, definitely please feel free to put that back in the question panel and we will readdress it. Thank you. All right. I'm going to turn it back over to you, Jeremy.
And I'm going to turn it over to Miriam.
Thank you. Yeah, we want to share some locations where curb ramps are commonly required. So on the next slide, we have some photos. Curb ramps are required at intersections, crosswalks, some driveways, and accessible parking spots. So we have asterisks by the intersections and driveways because, as Jeremy talked about in the scoping section, not every intersection is required to have curb ramps if there are no curbs or sidewalks. And similarly, not every driveway will have to have curb ramps. But we'll go into some more detail about all of these locations in the next slides. So at intersections, like Jeremy talked about, one curb ramp or a blended transition is required per crosswalk. And we'll talk about the differences between curb ramps and blended transitions later in the more technical portion. But a single blended transition that serves multiple crosswalks may also be used. Curb ramps are also required at crosswalks at every crosswalk. So like Jeremy talked about, this is the companion curb ramp situation where you need a curb ramp or a blended transition on each side of the crosswalk. Another detail here is that the crosswalks have to fully encompass the curb ramps, and that's just the ramp portion. So it does not include the flares, which we'll talk about in a sec. It's fine for the crosswalk to be wider than the curb ramp, but the curb ramp cannot be wider than the crosswalk. And we won't get too much into detail about marking of crosswalks, but this does apply to crosswalks whether they're marked or unmarked. And if they are marked, then the Federal Highway Administration recommends high visibility crosswalks, like what's shown in the picture. If there is actually no legal crossing, then you are not allowed to have curb ramps there. So this might happen at some intersections where crossing is prohibited. And in that case, there are certain things you have to do to make that detectable to someone with a vision impairment. So the easiest thing to do is to have landscaping or grass or some other kind of non-walkable area that separates the sidewalk or the pedestrian access route from the street. So that way someone who is blind or has low vision can detect that the sidewalk doesn't continue and that this is not a crossing. There's another option if you don't do landscaping or grass or something like that. You can use a vertical edge treatment. It has to be detectable, so PROWAG limits the bottom edge of that treatment to a maximum of 15 inches above the sidewalk. Then you would also have to put up a no crossing sign, which is shown in the picture, if you're prohibiting crossing there. One project example where this could come up is if you were resurfacing like a really long, maybe urban corridor where there are sidewalks at every intersection and so there are crossings. Your project would be required to put curb ramps at all of those crossings. And then if you weren't putting curb ramps, you'd have to do the things on this slide to prohibit the crossing. Driveways were one of our asterisk items in that introductory slide. So not every driveway requires curb ramps. And really the preference is to keep the sidewalk at the same elevation throughout the driveway. That's a more pedestrian-friendly design that avoids people having to ramp down and then ramp back up. But you might have to do a curb ramp in some retrofit situations. One key thing to know here is that PROWAG only requires detectable warning surfaces at those ramps if the driveway is either signalized or has yield or stop control. So if the driveway is not signalized or it doesn't have stop or yield control, then you don't need to put the detectable warnings. And then the last situation where curb ramps are commonly required is at accessible parking spaces. So here you need a curb ramp that serves the accessible parking space. This is kind of one of the rare situations where there's not a companion curb ramp because it's not a crosswalk. And so there's just one curb ramp that serves the accessible parking. PROWAG does not require detectable warning surfaces for these curb ramps that only serve accessible parking. They're not part of crosswalk. But ODOT's preference is to still install the detectable warning. And this is also helpful for blind pedestrians because it warns them that they're entering a vehicle space so that they can be aware of that. This next slide has some information about accessible parking. This was one of the newer topics in PROWAG, so you may or may not be familiar with this, or you maybe have not run into it in your work yet. When altering parking spaces on a block, you may be required to put in a certain number of accessible spaces. In some retrofit situations, your accessible spaces might just be at the corner, and then they're served by the curb ramp that serves the crosswalk. But in other maybe new construction cases, if you have accessible parking kind of mid-block, then you would need a curb ramp that serves that accessible parking space and is not attached to a crosswalk. Any questions on that section?
All right, thank you, Miriam. Yes, we do have, I've asked for clarification for one of the questions, and we do have another one also. Ryan is asking, what is the requirement on curb ramps at alleys and or unofficial streets?
I believe they are still required at alley crossings. Although Jeremy, you can weigh in.
Yes, that's correct. If it is a street for vehicular use, then the use of the detectable warnings and the provision of a curb ramp or a driveway apron, as some alleys have, is the appropriate design there.
Wonderful, thank you. Okay, so I didn't get a clarification just yet on this one, so I'm just gonna put this out there, and if this works for you the way that it is, then we'll answer the question, and if not, we'll wait for a little bit more of a clarification. But they're asking, in the sidewalk examples, are diagonals still okay?
Um,
We'll get to that one.
Aha. Okay. Well then, to be continued. Then that will be all for questions for now. Thank you.
Cool. Okay, next we'll jump into talking about the parts of a curb ramp. And before we do that, there's a brief definition of curb ramps that's provided by PROWAG. So a curb ramp is a sloped connection that's either cut through or built up to a curb. And curb ramps can be perpendicular or parallel to the curb or to the street that they serve, or they can be a combination. So we'll talk about types of curb ramps a little bit later, but this kind of alludes to the fact that the actual ramping portion could be perpendicular to the street or parallel to the street or both. And then the first line where it says that the sloped connection can be either cut through or built up. The vast majority of the curb ramps we design will be cut through the curb. Built up curb ramps are an option in PROWAG. They're usually only used like during construction and for temporary curb ramps, and that is also a future section. This slide shows you the components of a curb ramp. This is specifically a perpendicular ramp, which is kind of the common or typical design. So it's got approaches leading up to a landing. The landing's at the top of the ramp slopes down, and then there's a clear space at the bottom, and then you have flares that connect the ramp and the approaches. This is also shown on a photo in the next slide. So you have the landing towards the back at the top of the ramp. The landing has a slope running parallel to the ramp and perpendicular. And then the ramp itself is sloping downwards. It has the detectable warning at the end. You have your sidewalk area that's the approach to the landing and the ramp. And then the flares provide grading to kind of span in between the approach and the ramp. You also, in the foreground of this photo, can see the curb and then the street grade and the flare of the slope of the flares. And then we're going to talk about every component, but before we get into that, I do want to mention that not all components are required on all curb ramps. So one example would be flares. Flares are required if the area next to the ramp is walkable, like a sidewalk, and you can see that on the left side of this image. But if the area next to the walk is not walkable, such as grass or landscaping, then a flare is not needed, and that's shown on the right in this image. Okay, so the first part of the ramp is kind of leading up to it is the approach. This is tied to the same pedestrian access route requirements that are in PROWAG as far as running slope and cross slope. Often when you are putting in curb ramps, you might change the approach slightly to be able to better tie into the existing walk. So you might be replacing a panel or two to transition from the existing to the new curb ramp. This is especially relevant if maybe the existing walk isn't fully compliant, and so you might have a slab or a panel of sidewalk that transitions from that non-compliant slope to your compliant design. Next is the landings. So the landing is a level area for people in a wheelchair to turn before they access the ramp. 4 foot square is the minimum, but 5 feet square is preferred. And landings are only needed if someone has to turn to get to the ramp. So in this photo, if someone were walking along the sidewalk from the back of the photo towards the foreground, and then they'd have to turn to their left or towards the right of the photo to access that crosswalk. So a landing is required at that curb ramp because someone has to turn to access it. You might have other situations where The sidewalk and the curb ramp are both in the same direction, and so no turns are necessary, and then a landing would not be required, although a clear space at the bottom might still be required. The clear space at the bottom of the curb ramp, sort of similar to a landing, provides a turning area. So someone, if they go down the ramp and need to turn to actually access the crosswalk, then this clear area is needed. It has to be a minimum of 4 feet by 4 feet, and it has to be completely outside of any vehicle lanes. So any vehicles that are going at the same time as someone might be crossing, the clear area has to be outside of that space. This is shown on this image from the Multimodal Design Guide. So this is a diagonal ramp, so kind of no matter which crosswalk someone is using, they'll have to turn at the bottom of the ramp to align themselves with the crosswalk. So you're required to provide this 4-foot clear space for people to turn and orient themselves to the proper crosswalk. And that space has to be outside of the vehicle lanes. Flares are another curb ramp component. So this is a graded transition that goes from the curb ramp to the surrounding sidewalk. And like we said, this is only required in some situations where the ramp is next to a sidewalk or walkable area. The flare itself is considered not walkable, so it's not part of the pedestrian access route, but it does serve as a cue to tell someone that there's a ramp there. So this is what we were talking about earlier, how they're not always required. On the left, the ramp is next to sidewalk, so the flares are required. In the image on the right, we have the grassy area shown with zigzags in green color. So because of that grassy area is not walkable, then flares are also not required. And then we wanted to touch on gutters. They're not exactly a part of the curb ramp, but closely related. So the gutter is moving water away from the roadway and into the local drainage system. And it will have a slope that usually matches the roadway cross slope. And it's important that there's no lips or gaps in between the ramp and the gutter and the edge of pavement, because this could be a place where someone's wheelchair wheels or crutches get caught, and then it would be a hazard for them. The next slide has some more guidance on this issue. So if the curb ramp and then the gutter are too steep or there's too big of a change in grade between those, then someone in a wheelchair can actually bottom out and have their shoes or the bottom part of their wheelchair kind of getting caught in the pavement, and they could be stuck or it could be painful for them. So if the algebraic difference between the curb ramp slope and then the gutter slope is greater than 11%, you're required to put in this level strip. So it's just 2 feet, it's flat, and it kind of serves as a buffer in between the two steeper slopes so that someone does not bottom out or get stuck. So those are the curb ramp components. We can stop if anyone has any questions on those. And I will say that we're about to go into more detail about slope requirements for all of those components.
Thank you for that front loading little piece there. So let me see here. Our next question says for a two-way stop controlled intersection with sidewalks on all four legs, are curb ramps across the major roadway always required under ODOT ADA, or are there situations where they are not warranted? Is there any guidelines that spell out the warrants?
Curb ramps would be required if there's a crosswalk there. So the guidance in the multimodal design guide would be that it's kind of best practice to provide a lot of crosswalks, so at the same spacing as the street grid itself. If people want to drive there, then they probably also want to walk there, and it would be best to provide a crosswalk. But I don't think there is a requirement to provide a crosswalk, and you could do the things that we talked about on one of the earlier slides where you separate the sidewalk from the street with a non-walkable surface and put up the no crossing sign. That is an option.
And again, to Miriam's point, it relates to whether there is or is not a legal crosswalk there. And by legal crosswalk, we mean a marked or unmarked crosswalk. So for example, if there is a sidewalk on your main street that is uncontrolled, and you also have a sidewalk on the intersecting side streets that are stop controlled, then the promulgation of that sidewalk across that intersection is a legal crosswalk, whether you mark it or not. And so, because there is a legal crosswalk there, it would require either the provision of the curb ramp, even if you're not going to mark the crosswalk, or the landscaping with the no pedestrian crossing sign.
Thank you very much for that clarification, both of you. Okay, next question from Elida. Is the approach part of the curb ramp for estimating?
No. If the slope of the approach is not a ramp slope, if it's not steeper than 5%, then it would not be part of the curb ramp for estimating.
Okay, thank you. Next question from Brianna. Just confirming for parallel ramps, landings are not required at the top of the ramp if no turning is required?
Yes.
Awesome. All right. We have more questions. Let's see here. Next question from Jeremy. Do you have a visual example of when a landing is not required at a curb ramp? Are there any running slope restrictions in this situation?
We'll have images of that in the next section.
Awesome. Y'all thought of that already. Wonderful. Let's see here. There's more. Let's see here. The standard slope on ODOT combination curb and gutters is 12 to 1, 8.3%. How would someone make this work with the 5% max gutter street slope?
I think it essentially requires warping the gutter.
Okay. All right. Very good. We have another, it looks like maybe a clarification. This person says, I thought that single curb ramps weren't allowed at crosswalks, but I've seen multiple examples of it. I thought that they need separate curb ramps as you need to push buttons 5 feet apart.
Yes. I think we'll have a section on diagonal curb ramps later. So a single diagonal curb ramp is not allowed for new construction under PROWAG. And it can only be used in alterations if it's not feasible or practicable to provide 2 separate curb ramps at the corner.
Okay, very good. And last question. If you warp the gutter and raise the gutter plate, how do you not trap water?
So the slope of the flow line will still remain constant. It's altering the sort of slope in the direction of a pedestrian crossing. And so you have a few levers to alter. You can alter the slope of your ramp and lower it, or you can alter the slope of your gutter, or you can change both of them. But the longitudinal slope along your curb line is not going to fundamentally change or would not change much. And so you would not be trapping water by creating sort of a localized low point or anything like that.
Wonderful. Thank you. That's all the questions we have for now.
Okay. Well, next we'll jump into the different types of curb ramps and walk through their different design elements, some of the design challenges associated with them, so that you're all familiar with those specific topics. So ODOT does use 4 different curb ramp types. They're categorized by tiers, with tier 1 being the primary or preferred design, and that's the perpendicular style curb ramp. And essentially, designers should not default to a lower tier unless they've determined that the upper tier is not going to be constructible. And that evaluation could be based on a number of factors: the scope of your project, whether there are drainage features or utilities in the way, right-of-way restrictions if right-of-way acquisition is not one of your project components, as well as operational or geometric features. So again, perpendicular ramps is ODOT's preferred design, and you can only move to those lower tiers if you can't construct a perpendicular style ramp. Tier 2 is a combined ramp type, so it has elements of a perpendicular ramp. So the best example is that image on the right, showing the sidewalk having a portion of a parallel style curb ramp, and then the connection to cross to the crosswalk is fundamentally a perpendicular style ramp. But tier 2 is a combination of multiple curb ramp types. Tier 3 is a parallel style curb ramp where all the ramping is occurring in line with the sidewalk, and then the landing itself is serving as the transition into the street. And actually, this tier 3 image is a good example to the question earlier of a location where a landing is not required at the top of the ramp, because a person using a wheeled mobility device does not need to reorient themselves to align with the ramp itself. The only turning is happening at the landing once they get to the bottom of the ramp and turning to orient themselves with the crossing location. And then finally, tier 4 is the diagonal style ramp. So you can only do a diagonal curb ramp if you can prove that you weren't able to provide perpendicular ramps, a combination, or a parallel style ramp to address each crossing location. And this aligns with what PROWAG says. It's very clear that a diagonal ramp shall only be provided if the provision of other types of single ramps for each crossing is technically infeasible. So walking through in a little more detail each of the curb ramp types using ODOT's design details. This is showing that tier 1 design, a perpendicular style curb ramp. Each of those does have a landing at the tops of the ramp. That perpendicular orientation can be along the tangent section of your roadway or on the radius at your intersection. So the image on the left is showing it on the tangent section. The image on the right is showing that installed along the radius of the intersection. Again, showing that design with the details used in ODOT's design. landing at the top there. And again, that is to reorient themselves to the orientation of the crossing before proceeding down the ramp. ODOT does have guidance in the multimodal design guide talking about whether a perpendicular style ramp or a directional ramp, which we'll discuss in a moment, should be considered. And that relates to the orientation of the perpendicular style ramp to the orientation of the crosswalk alignment. And so if we had a design as shown here, but our crosswalk in the street is sort of a skewed orientation that would exceed a 20-degree angle compared to the angle of the curb ramp, that's where we would consider doing a directional style curb ramp. But again, perpendicular ramps are the sort of common classic design for a curb ramp. It's worth noting that a simple broom finish is preferred. The image shown here using an imprinted pattern with the idea of providing additional traction is a flawed approach. And that PROWAG wants the surfaces to be firm, stable, and slip resistant. And so simply using a broom finish is going to be preferable for the curb ramp installations. Now, up till now, all of the perpendicular ramps that we've been showing have a single landing to access each one of those locations. But in tight locations, you can actually have a single landing that serves multiple directions of crossing. And so that's what this image is showing. You have two perpendicular style curb ramps, but where they meet at the top at the sidewalk is a single landing that serves to orient to either crossing direction. That is an acceptable design. And again, we have to sort of identify the design that will work within the constraints of our individual site conditions. I'll also note that this image is showing the use of the brick detectable warning surfaces. We generally don't recommend those because they do tend to be dislodged and require a little more maintenance. The nubs on them chip off, and so relying on the plastic or cast iron is usually preferable. So this is what I was talking about before, the difference between the perpendicular and the directional style curb ramp. So if you look at the image on the right, the upper portion of that is showing that angle that I was talking about, that if the orientation of a classic perpendicular curb ramp measured against the alignment of the crossing location, like the crosswalk orientation, if that Z angle exceeds a 20-degree angle, then we would want to consider providing a directional curb ramp, meaning aligning the orientation of the curb ramp itself to the direction of the crossing. And you can kind of see that in the lower part of that image, where it is showing a small triangular area, and that's always a telltale sign that is a directional curb ramp. And you can see that that crossing, that curb ramp perfectly aligns with the orientation of the crosswalk. Now, PROWAG does require that one curb ramp be provided for each crossing, and whether that's marked or unmarked, but also allows a single blended transition that would span across multiple crosswalks. Now, you can only do that if your crosswalks are really close, and we'll discuss some of that a little later, but PROWAG does provide that as an option. We've already discussed that you have to have the landing wherever you have the turning area, as well as that clear space at the bottom of the ramps. So when it comes to directional curb ramps, if we have identified that the orientation of our crosswalk in relation to a standard style perpendicular ramp is exceeding that 20 degrees, then we seek to align the orientation of the directional ramp with the orientation of the crosswalk. And when we do that, we look and measure what is the distance from our curb line to where the detectable warning surface would be located on a standard design for a curb ramp. So that's what we're seeing on the left here. if that distance is less than or equal to 5 feet from the curb to where that grade break or detectable warning surface would be, then we leave the detectable warning surface as shown in that image on the left at the grade break. But in a very skewed condition, if that distance were to exceed 5 feet, PROWAG and ODOT's guidance requires that those detectable warning surfaces be aligned with the curb line itself. Essentially, anything longer than that 5 feet is going to be difficult for a pedestrian to understand the condition and isn't clearly communicating where the edge of the vehicular space is. So it requires that those detectable warnings be radial or pulled out adjacent to the back of curb. And in that case, ODOT recommends that we then shift the grade break back so that we are not cutting or putting part of the detectable warning surfaces on the ramp and then part of them on the triangular area at the bottom of the ramp. Really, that relates to maintenance and longevity. If you cut detectable warnings, that's going to become a point of failure. And worth noting that that triangular area shown in both of these designs is considered a clear area. You do want to alter the slope of that to tie in with your crossing, so it will not match the slope of your road of your ramp itself. So you do have a grade break. We'll use the image on the left. You'll have a grade break at the edge of those detectable warning surfaces, and then your triangular area will sort of flatten out to allow that transition to occur. And so ODOT's details reflect what I was talking about with the location of that grade break. You can see in the upper part of the detail, it's showing the grade break being located at the back of those detectable warning surfaces. So why do we do why do we do directional style curb ramps? Well, it does help a pedestrian with a vision disability to begin their crossing sort of aligned with the crosswalk orientation, but perhaps more importantly, it ensures that a person using a wheeled mobility device does not need to reorient themselves within the street and reduces their exposure, that essentially the curb ramp perfectly aligns with the direction of their crossing. They can proceed down the ramp and continue their crossing without changing direction. And as I was saying before, you can always tell a directional ramp by looking at the triangular area that exists at the bottom of that ramp. And so next to the person on the right, if you look at their feet, you can see there is a triangular space between the back of curb and the detectable warning surface. And you can also see that this curb ramp perfectly aligns with the direction of the crossing itself. When it comes to the Tier 2 style design, that's that combination of a perpendicular style ramp and a parallel style ramp. ODOT has the design details for that in the C1 and C2 style design. And really the difference between that is whether you have a walkable or unwalkable surface immediately behind the curb. So C1 with flares is appropriate if you do have a walkable area. The standard style parallel that then transitions to the perpendicular that's shown on the right would be correct if you have an unwalkable area. And the nice thing about combining different types of curb ramps is it can more logically align with the topography that we're encountering in specific sites. And so in this case, by providing a parallel style ramp that lowers to a single level, that reduces the length of our perpendicular style ramp and also reduces the need for changes in grade to connect from one curb ramp to another. And so this is a very useful style design when we have sort of constrained conditions and are trying to work through the grading challenges that we encounter. And then in our most constrained conditions, where we have a curb tight sidewalk and no buffer between our curb line and the sidewalk itself, that's where the tier 3 style design is appropriate. And so providing the ramp down to the landing, reorienting to proceed along that crossing. Now, why is this design a tier 3 style design, not a preferred style design? Well, there are a lot of shortcomings with this type of ramp, and that's why it is not high on the list of tiers. Um, these style designs, by putting the landing um, at the edge of the curb, means that when stormwater flows along here, it does want to spread out into the curb ramp. It will also then slow down because you have a wider area of flow, and that often causes any suspended solids or sediment that is in that stormwater to then deposit out at the curb ramp itself. So not only is a pedestrian who's trying to cross here during a storm having to cross a wider area of flow than they otherwise would have at a perpendicular style ramp, but it often means that there's also then debris even after the storm has passed. And so while it's always good practice to install an inlet upstream of a curb ramp so that a pedestrian crossing any curb ramp doesn't have to sort of ford a stream to proceed along their crossing, this style curb ramp, it's even more important to address that collection of sediment and spread of flow that tends to happen. This is again another good illustration of there aren't turning areas at the tops of the ramp, and that all of that turning happens at the landing at the base of the parallel style ramp. In constrained conditions, this is also the location where we would have cheek walls or curbs along the back of the curb ramp to limit our areas of disturbance. And then any push buttons that are located would be located adjacent to this landing, not at the tops of any of these ramps, because essentially a person who's beginning to or wants to proceed along this crossing would want to be waiting at the landing at the base of the parallel style ramp. And then in situations where you would want to ramp up between one parallel ramp and another, that ramp up needs to at least be 2 inches high to provide a detectable curb in that area. Full height would be preferable, but we don't always have the space to do that. And then if we are raising that up, it does then require us to have a clear space at the top of that ramp up before you then transition to the next ramp down. So you wouldn't have a ramp up immediately connecting to another ramp down. You need a little space to transition from one to the other. And then parallel ramps can also come in different flavors. So if we look at B2 on the left side of that image, that's a parallel style ramp where the sidewalk continues along the corridor. So we do have a ramp up and a ramp down. B1 is where essentially the crossing is the end of our sidewalk. So we only have one ramp to then cross the street. And then B2 is showing a curb tight style parallel ramp with a clear space at the base of that ramp at the bottom of the parallel style ramp. And then oftentimes it's a possibility to take curb ramps that were well-intentioned but non-compliant and provide a little bit of space behind them to construct to complete a compliant ramp. So if the slopes and grades of this condition met all of the criteria of ODOT and PROWAG, then we could widen the sidewalk behind those ramps in order to create the landings needed. I've seen this happen on a few projects where we actually don't have to disturb the curb ramp and just need to do a little bit of widening behind the curb ramp itself. ODOT does also provide guidance on the placement of curb ramps, and this isn't something that PROWAG discusses, but it is an important design consideration. So the image on the right is a good example of this, that if we located the crossing location at location 1, well, that would provide both a perpendicular ramp that is also a directional ramp, but it would put our crosswalks really far from the intersecting side streets. Location 2, where it's just an extension of the sidewalk in each direction, that would provide the shortest crossing or the shortest path of travel for a pedestrian. They wouldn't have out of direction travel, but that design would result in a diagonal style curb ramp and the longest crossing distance for a pedestrian. So location 3 is sort of identifying that sweet spot, that it is a ramp that is putting a crossing location in a place where the crossing pedestrian is going to be visible to a turning motorist, while also balancing the crossing distances for the pedestrian. Any questions on those style ramps before we talk about diagonal ramps?
Okay. I just want to let you all know as I come live, as I unmute myself, that they have just announced over our PA system here at the ODOT office that they are practicing some things with our fire alarm system. So I just want to let you know that if all of a sudden I go mute, that's probably why. I will be right back as soon as I can. I apologize for any inconvenience this causes. So sorry. But we do have some questions, and I will jump right into those. Um, so thank you for understanding. And Paige is asking, can you speak to what research was performed supporting no longer allowing diagonal ramps in new construction?
Can I speak to the research? Um, I'm not sure that I can. Um, the Access Board did a lot of engagement over the 30 years of developing PROAG and identified the challenges associated with diagonal ramps as being not only that they don't align with the crossing locations, but they also increase the exposure of a pedestrian, because a person has to not only orient themselves within the street to continue their crossing, um, but they're also in a very constrained space adjacent to different directions of moving traffic. And so the benefits of providing separate ramps far outweighed the design of providing a single ramp that is serving both directions of travel. So after significant engagement, that's where they settled that that is the lowest tier and can only be considered if all other options are technically infeasible.
Aha. All right. Thank you for that. Okay. Next question from Connor. The brick inlaid detectable warnings aren't preferable, but are they still considered compliant?
I mean, they're technically compliant if they meet all the dome or yeah, the spacing and placement criteria. The challenge with them is that more often than not, they settle differentially over time and require a significant amount of maintenance in order to keep them in compliance. And that's the real challenge with that style of detectable warning surface, that they might be great on day one, but a year or two later, the nubs will have chipped off, the domes will have chipped off of them, a couple of the bricks will have settled, and I've seen plenty of examples where the bricks also, some of them are missing. And so um, it just means more cost for the agency to maintain.
Yeah, I'll also add that for ODOT projects, or if you're using ODOT specs, brick products for the detectable warning surface are not allowed in the spec book. So in the construction manual, construction materials and specifications, brick detectable warnings are not allowed.
Thank you for that. That makes sense. Okay, we have a question from Christine, and she asked, is there a max distance from the point of curvature that a ramp can be placed?
There's not a max distance, but if you are, particularly if you have an intersection with a large radius, if you are trying to locate your crosswalk as a perpendicular ramp on the tangent, inevitably that crossing distance is going to be so far from the intersecting roadway that the pedestrian is not going to be visible to the crossing user. Some comparable research that was done for protected intersection design, and this was evaluating motorist yielding to crossing bicyclists, not pedestrians, found that the sweet spot of getting motorists to see and yield to crossing bicyclists was between 6 and 16.5 feet from that intersecting roadway. And so that's a comparable rule of thumb that I would use for crossing pedestrians, that if you're 25 feet away from the intersecting roadway, that's just going to be too far away from the intersection to make that pedestrian easily visible to a crossing user. Similarly, you don't want to put it right up against the edge of that travel lane because it gives no space for a motorist to yield to a crossing pedestrian.
Fantastic. All right. Next question is from Morgan. If you push to get the two ramps in at a corner, how much space or how high of a curb should you have between? At what point do you make it one ramp or use blended transition ramps?
Yeah, at least 2 to 3 inches to ensure that that curb is going to have some detectability to a pedestrian on the back side of it, and potentially more importantly, so that there is some amount of curb reveal so that drivers aren't encroaching into the pedestrian space.
Wonderful. Okay, next question. You guys are really popular. Let's see here. Next question from Jeremy. In the ODOT SCD for the parallel ramps, could you provide a landing at the top for the B3 ramp instead of at the curb line since the roadway grade is not typically at 1.56% compliant cross slope?
So a landing for a parallel style ramp should only occur at the base of that ramp where the person is turning to orient themselves to the crossing direction. I've been in this situation before where an agency believed that a landing needed to be incorporated at the top of the ramp as well, with some belief that that's a rest area for a person before they navigate the ramp itself. But the flaw of that thinking is that if you are on a steep road or even a minorly sloped road, let's say 5%, if you try to incorporate a landing at the top of that ramp, that inevitably means steepening the transitional panel from that landing back to the existing sidewalk. So you're actually creating a condition that can be more challenging for a person using a wheeled mobility device to navigate.
Wonderful. Next question from Kurt. What is the difference between A3 and B3? Why is one parallel and one is perpendicular? When both are perpendicular to the curb of the street they are providing access to.
You're testing me on memorizing A3 and B3. Give me one second.
There might be another question on that too, just a heads up. Maybe.
A1. Did I miss it in here, Miriam? Let's see.
It's possible that we don't have a photo of A3.
Can you speak to that one then, Mariam?
Yeah, Kara, could you repeat the question?
Absolutely.
Thank you.
What is the difference between A3 and B3? Why is one parallel and one is perpendicular? When both are perpendicular to the curb of the street, they are providing access.
Mm,
Maybe we did have it in the previous section. Maybe not.
I was going to say, I'm assuming it was a pretty recent one because this question was asked within the last 10 minutes, maybe even more like 8 minutes.
Mm-hmm.
Hmm, I
Hey,
don't
this
know.
is
Let's,
Jen Alford with ODOT. I just want to butt in here. We can certainly answer that question at a later time. I don't know the history of why they're called A1, A2, A3, but we can certainly track that down for you. We can get in touch with them later, right?
absolutely.
Okay,
Yes.
that sounds like a plan.
Kurt,
Thank you.
please reach out to Jen. There we go.
Thanks.
Okay. Thank you, Jen. All right. Next question. Is a 1 inch, I think this means flare, always required by ODOT?
I think the standard drawings show a 1 foot flare.
Okay. Let's see if because there might have just been a little bit of a typing situation on that end then. Let's see here. On the left picture of the previous slide, would the landing be required at the intersection of the sidewalks and not required prior to the ramps if parallel ramps didn't require landings?
Yeah,
Hmm.
in the image on the left here, the landing as shown wouldn't be required at the top of the ramp. It would be preferred at the intersection of those two sidewalk intersections. That's totally true.
Ah, that makes sense. All right. Let's see here. Okay. How will stormwater drain away from the landing?
In a parallel style curb ramp is what I'm assuming um, the question is referring to. And so in a parallel style curb ramp, we'll go back to this image. Um, so there is still a requirement that the slope be from the back of the sidewalk or back of the landing towards the curb line. So there is still positive drainage. It's just that because it's a landing, it means it's a relatively shallow slope. And so that's what I was saying, that if stormwater is flowing along the curb line and it's up against a vertical surface, and then all of a sudden that vertical surface isn't there and you have a relatively flat area, it does mean that stormwater wants to spread out and start to get into a portion of the landing itself. And that's why it would be preferable to install a drainage facility upstream of this location so that the volume of stormwater that's reaching the curb ramp is minimized.
All right. Wonderful. Uh, Aaron is asking, are there any concerns with a ramp that may have a lower landing that is within the through travel lane due to a limited curb radius?
So if we're talking about, let's say, the image on the right here, each of the crossing directions, the clear area at the bottom of the ramp is outside of the path of the direction of travel that would be allowed to go at the same time that the person is crossing. So I don't think there's an issue with that. And actually, this is the common challenge with a diagonal style ramp, is that it, particularly on a corner that has a small radius, it can sometimes be impossible to create a clear space at the base of a diagonal style ramp that would be outside of the path of both directions of traffic that could be allowed to go at that intersection. So it's diagonal ramps kind of only work if you end up having a large radius. Otherwise, you have the clear area in conflict with the travel lanes.
That makes sense. Okay. Sorry about that. One moment, please.
Luckily, it's fairly quiet on our end.
Okay, success. They've concluded the fire alarm test, so sorry about that. Okay, let's see here. There's a photo of a ramp with brick or a stamped brick pattern on the ramp itself. Is that acceptable?
It is not preferable. The
Mm,
PROWAG requires surfaces to be firm, stable, and slip resistant. Concrete is going to be preferable for a curb ramp. Asphalt or concrete are going to be preferable for a shared use path or sidewalk. Um, and as Miriam was saying, the brick isn't allowed on ODOT projects. So even in locations, I've done plenty of projects in historic character locations where there was a desire to use bricks or pavers as part of um, the design of the sidewalk environment, but all of those instances have still used concrete for the ramp itself, and that just helps to avoid any um, long-term settlement issues that tend to happen with bricks and pavers.
okay. And Jeremy is asking back on the slide, on the last slide of this section. He must have noticed had a question when you were back there just a second ago. Is the level landing pad on the left image required since it is not a turning space?
And yeah, that's what I was saying with the previous answer, that the image as shown is probably incorrect, because at the top of the ramp, these are essentially parallel style ramps.
Mm,
Well, I guess they're perpendicular ramps that do not require a turning area at the top of the ramp. So a level landing would not be required there, but would be appropriate at the intersection of the two sidewalks themselves.
Wonderful. Okay, and we did get clarification on the question about the flare. They said yes, they meant is a 1 foot flare always required by ODOT? Was their question.
Yeah, it's shown in the standard drawings. I'm not sure if it is always required.
Okay, wonderful.
It's a
We've got two.
it's a 1 foot minimum, so
Oh,
higher than that.
thank you, Jen.
One thing I'll note, so in an example where you are doing a flare, that's because you have a non-walkable area adjacent to your curb ramp. I tend to find that if, like, we'll take the image on the right as a good example. So that is showing a non-walkable area, but showing a fairly long flare. And what I tend to find when this gets constructed like this with a big flare, that pedestrians will walk over the small angle of the grass and end up killing the grass or landscaping in that area. So there is a benefit to minimizing the size of that flare when you have non-walkable area, because it will encourage pedestrians to use the paved and hardened space.
I can confirm that. Thank you for pointing that out. Okay, one of our last questions. Brianna asked, at signalized intersections, is it correct that a push button is required to be adjacent to a landing? This could require a ramp to have a landing that is not necessarily a turning space.
It is not required to be next to a landing in some cases, and we will cover push buttons, so I won't answer any more on that one.
All right, very good. Then that takes us to our last question for this section. If profile grade of side street, okay, I'm sorry. This one's a little tricky to read. Let's try this again. Okay. Okay, sorry about that. They wrote it out like they would speak it. So if the profile grade of a street is 4%, is it allowable to match this slope at the bottom of the ramp where the cross slope will be at 4% in case where, in this case where it meets the pavement?
So this is relating to the longitudinal slope along a curb line, and do you need to alter the slope at the crosswalk location? And this relates to the required slopes within crosswalks. PROWAG identifies these as being tied to the type of control that exists at that crossing. And so a stop or signalized intersection has different slope criteria. And the Access Board has sort of acknowledged that this is going to be easy with new construction projects, but can be a challenge with alteration projects. And so you might be able to alter slope slightly with variable milling and minor adjustments, but you might not always be able to fully meet the criteria outlined in PROAG.
All right, wonderful. Thank you for that. Okay, we have reached the end of our questions for that section.
Okay. Well, we'll jump into diagonal ramps, which, as the slide says, they are not preferred. They are a case of last resort.
Just real quick,
Oh,
Jeremy,
yeah.
can I get an idea from you about when could our attendees expect a break?
I feel like we could do it at the end of this diagonal ramp section.
Okay, sounds great. Thank you so much.
So the diagonal ramp, it is allowed if all other things have been considered and proven to be impossible or technically infeasible, but they do have their own criteria as well. So they are similar to a perpendicular style ramp, but the turning space at the bottom of the ramp will serve both directions of crossing. And that's what I was saying before, that it is very difficult to get that clear space at the bottom of the ramp to be wholly outside of the adjacent travel lanes, particularly if we're talking roads where the travel lanes, be it bike lane or vehicular travel lanes, are immediately adjacent to the curb. It's a little easier to do if we have on-street parking, because that on-street parking sort of shadows that clear space at the bottom of the ramp. But as I said, it's only permitted if two separate ramps or a blended transition are technically infeasible for those reasons that we discussed, that it just creates longer crossing distances and increases a pedestrian's exposure within the roadway itself. We already kind of discussed this, but that would be location number 2. So, it just sort of aligns with the direction of the sidewalks themselves, but increases the crossing distance for pedestrians. I know we had lots of questions about diagonal ramps in the last section, but happy to answer any more people have specific questions.
Believe it or not, we do not have any questions.
All right, well then, yeah, let's do the break now and we'll pick up the pace when we come back.
Sounds great. How long would you like to give our attendees a break for?
Miriam, what did we say on that one?
I think we said 5 to 10. I'm kind of leaning towards 5 right now.
Given the volume of great questions we're getting. Yeah, why don't we do 5 minutes?
Wonderful. All right, so everyone, please come back at 10:46 and we will jump right back in, starting with slope requirements. Hello, everyone. It's 10:46, so we are going to go ahead and get started again. Um, just something to think about as we move through the rest of this presentation is if we want to consider possibly having a second session, maybe, since we are, taking the time to stop and answer the questions, the really good questions. But I'm not sure that we'll, if you think we'll be able to get through the entire presentation, that sounds great too. But if you think maybe we should possibly consider, having a session two, we could look into possibly doing that. So just something to think about as we move through this, and the amount of time that it takes to get through the content that you all are sharing, because this is great. All right, I'll turn it back over to you.
All right, next we'll talk about slopes themselves and an understanding of what guidance we see in PROWAG and what guidance is in ODOT's guidance. So that will include slope requirements for crosswalks, ramps, landings, the approaches, as well as flares. So first up is crosswalks. And this is what I was saying before, that PROAG ties the slope of a crosswalk to the type of control that exists at that intersection. It says that, and I want to make sure we're all using the same terms here. So when it comes to the grade of a crosswalk, the grade is referring to the slope in the direction of the pedestrian travel. That's the same as the cross slope of the roadway if we're thinking of roadway cross sections. By comparison, the cross slope of a crosswalk is the longitudinal slope of the roadway. So when you're thinking of accessible requirements, make sure that you're orienting yourself to the pedestrian, since that's the terms that PROAG uses. So the grade of a crosswalk shouldn't exceed 5% unless you have a super elevated roadway, in which case it can match that slope. When it comes to cross slopes, that's where it's tied to the control. So it's 2.1% max at a yield or stop controlled location, a cross slope of 5% max at an uncontrolled, signalized, or a location with a pedestrian hybrid beacon. And finally, a cross slope at a mid-block crossing that is uncontrolled or at a roundabout cannot exceed the slope of the grade. When it comes to curb ramp slopes, the numbers in black are what were identified in PROAG. By comparison, the numbers that are in red, the lower slope values, those are ODOT's more conservative values. And the reason for those conservative values is to address constructability and ensure that if you design all the way up to that max slope from ODOT's guidance, that when the contractor actually goes to build it, they will still fall within the allowable slopes within PROAG. That also is important to know because there could be times that you need to exceed ODOT's preferred slopes. And so in those cases, you should still be striving to stay with underneath of PROAG's requirements. Otherwise, it is a technically non-compliant ramp from the US Access Board's perspective. So the curb ramp slope is 8.33 from PROAG's perspective, 7.69 from ODOT's perspective. We already talked about that change in grade at the bottom of the ramp. It's important to note from the slope of the ramp that you are striving to meet that maximum allowable, whether it's ODOT's or PROAG's, and that you are required to sort of chase grade for as much as 15 feet. Anything more than 15 feet would just result in an incredibly long curb ramp that's not very useful to a person with disabilities. And so that is the maximum length for a curb ramp. And if that meant that you needed to provide a 15-foot long a slope that exceeded the allowable, that's technically acceptable. When it comes to the landing of a curb ramp, the landing in the direction of travel from PROWAG's perspective is 2.1% max. ODOT's preferred is 1.56% max. And then the cross slope of the landing, ODOT says it's 1.56%. But what PROWAG actually says is that cross slope can't exceed the slope of your adjacent roadway or the slope of the adjacent ramp. And the reason behind that guidance from PROWAG is the access board really doesn't want us to include warping within a ramp. So essentially PROWAG is saying whatever the slope is in the crosswalk, you should carry that slope into your ramp and carry that slope into your landing. By comparison, ODOT's detail shows the 1.56% in all directions. And again, the landing is only required if the person in a wheelchair needs to reorient themselves at the top of the ramp. So sort of illustrating what I was saying there, PROWAG's guidance is whatever your roadway profile slope is, your ramp slope should generally match that, and the slope of your landing should generally match that. And in this case, we actually have a shared landing, and so the cross slope in each direction would match the corresponding slope of the adjacent roadway. And any transitional slope changes would occur in the transitional panels beyond those curb ramps. The approach slopes should generally not exceed 5% or the slope of your roadway, whichever is greater. And I think that responds to the question we got earlier. If you have a steeper slope roadway, then the sidewalk shouldn't exceed that steeper slope. And then the cross slope of that sidewalk shouldn't exceed the 1.56 recommended by ODOT. When it comes to flares, the maximum slope, both from ODOT and PROWAG's perspective, is a 10% slope. And generally that's measured parallel to the curb line. If you're providing 10% parallel to the curb line and you're providing a compliant curb ramp slope, then anywhere along that flare won't exceed the 10% slope. So that's the easiest way to check for compliance on that one. Do we have any questions on the slope criteria?
We have one quick question. Will a landing reset a curb ramp's length? For example, can you have a 15-foot ramp, then a landing, then another 15-foot ramp?
Could you have that? I think if you did, you would be getting into a situation where you are no longer designing a curb ramp, but instead you are designing a series of ramps and landings, similar to what you'd have to have a shared use path, overpass, that sort of thing. And that design has very specific criteria when it comes to the placement of handrails and things of that nature. And so PROWAG's pretty explicit that if you have to exceed the 15 feet to get compliant slopes, then it's just creating a situation that is you're in a steep roadway condition and you're chasing grade forever. And so it would be recommended to just provide the 15-foot long curb ramp and tie into your existing sidewalks and proceed at the adjacent slopes of your adjacent roadway. That's a really good question, though.
Yes. Thank you so much. I'll let you move on.
All right, I'm going to pass it over to Miriam.
Thanks, Jeremy. Okay, we're going to talk about blended transitions now, which are very closely related to curb ramps. PROWAG provides this definition of a blended transition: a wraparound connection at a corner, or a flush connection where there is no curb to cut through other than a curb ramp. This definition can be kind of confusing, so hopefully these pictures help clear it up a bit. These are a couple different kinds of blended transitions. The main criteria is that it's more flush than a curb ramp. So the maximum slope here is 5% instead of the 8.33% per PROWAG or the 7.69 per ODOT. On the left, is kind of similar to the curb ramp pictures that we've been looking at. On the right, these are also sometimes called fans or depressed corners. And although it looks similar to a diagonal ramp, it's not a diagonal ramp. First of all, because of the difference in slope, but then also because it doesn't require someone to change directions at the bottom of the ramp. There are a few advantages for blended transitions. So one of the advantages is the more gentle slopes. So because it's under 5%, it is easier for people with disabilities to navigate blended transitions compared to curb ramps. And because the grades are all more gentle, there are no sharp grade breaks. There's also no landing needed at the top because it's not a ramp. And so there's also no turning space needed at the bottom. And having these consistent slopes where it's the same as like the sidewalk leading up to it can simplify the overall design. What's shown in this picture is a raised crossing. So this is one instance where you might encounter or might design a blended transition. So you can see that the roadway is actually ramping up as it approaches the crosswalk rather than the sidewalk ramping down. There are a few other considerations to think about when considering specifically a depressed corner type of blended transition. One of the challenges with this design is that it can be difficult for people to detect the boundary between the sidewalk and the street because it's a very large area where everything is flush and at a similar elevation. So it becomes really important to have the detectable warning surface across the entire blended transition area. Kind of related to the flatter grades, it means that it's easier for people driving to encroach onto the sidewalk while they're making turns. And then another challenge is that a driver who sees a pedestrian entering or using a blended transition or a depressed corner might not always know which crosswalk the pedestrian is going to. So it can add like a little element of confusion or unclarity. And then one advantage of a depressed corner is that it does allow a larger volume of pedestrians to cross. And so that's why you might see this design or consider this design at like really high activity urban areas, maybe in a downtown core or like on a college campus where a lot of people are going to be crossing all at the same time. This shows the slopes that are required for designing a blended transition. And then in this image, it's a depressed corner. So the running slope shown by the like chunky black arrows is maximum 5%. But there's also a bypass or basically a sidewalk required behind the blended transition. So this is for people who are just continuing walking around the corner. They're not using the blended transition. And so this area is subject to the same pedestrian access route requirements covered in PROWAG. So maximum 2.1% cross slope for the pedestrians walking that way. It is parallel to the blended transition slope. And then a minimum 4-foot width. So we talked about how one of the challenges with blended transitions and with depressed corners specifically is that you have this really large area that's flush. So it can be difficult to tell where the street ends and where the sidewalk starts. Another challenge is that this design doesn't really give any directional information to people who have vision disabilities. So it can be hard to kind of orient themselves to whichever crosswalk they're trying to use. So one approach that you could consider is introducing a small, like a short median or section of curb where the bollard is in this picture. So this could be 2 to 3 inches tall. And it would help not just with the vehicle encroachment issue, but it would also help pedestrians to orient themselves to the crosswalk that they're trying to use. Do we have any questions on blended transitions?
We do not have any questions at this time.
Okay. Well then I'll keep going and talk about detectable warning surfaces. I feel confident that we've all seen one before because it's Jeremy's background photo. This detectable warning surface is a surface feature that tells people with vision disabilities that they're approaching a crossing. It's not a wayfinding device, it really is just like a warning that they're about to enter a vehicular space. They're also sometimes called truncated domes, so you might hear both. There are a lot of specific requirements for the dimensions of truncated domes or detectable warning surfaces. And these are all outlined in PROWAG. I'm not going to spend a lot of time on them because as a designer, you probably don't need to know all of the specifics because detectable warning surface manufacturers do know the specifics. And the dimensions for these haven't changed in the latest final rule from PROWAG. So manufacturers should already know how to manufacture these to be PROWAG compliant. For designers, what's more important to know is the dimensions of not the specific truncated domes, but the overall detectable warning surface. So it has to match the width of the curb ramp. And then it has to have a depth of 2 feet minimum. So the ramp has a minimum width of 4 feet, but the detectable warning really has to match the width of the ramp. So if you go wider than 4 feet for your ramp, you can't have only 4 feet for the detectable warning. It has to match the same width as the ramp. A few other requirements are that there has to be a contrast between the detectable warning surface and the sidewalk. So either a light detectable warning on a dark walk, or more commonly a darker detectable warning on a light colored walk. And then for ODOT specifically in the spec book, there are a few requirements on materials to use for detectable warning surfaces. So some of the materials that are allowed include cast iron, stainless steel, and the reinforced polymer composite. And then some of the materials that are not allowed in the ODOT spec book are what we talked about earlier, so brick products or stamped concrete. Those are both not allowed. There are a few specific things about the placement of detectable warning surfaces that we should know. So I already mentioned that they should be 2 feet wide, and then I'll talk about both of the dimensions that are labeled in this bottom photo. So first, the 2-inch max dimension. This is basically an allowance from PROWAG where if a concrete border is needed to properly install the detectable warning surface, then that concrete border is not to exceed 2 inches. And then the second dimension in the picture, the 6-inch max, what PROWAG says is that the detectable warning surface should be installed at the back of the curb. And then if there isn't curb, then the detectable warning should be a maximum of 6 inches from the edge of the pavement. So in this photo, really the detectable warning surface should have been installed right at the back of the curb. Jeremy's kind of already talked about how detectable warning surfaces relate to grade breaks for directional ramps. But just to reiterate, you'll install the detectable warning surface, basically one corner would be at the very back of curb. As long as the distance from the closest edge of the detectable warning to the back of curb is no more than 5 feet at the farthest point. And then if that distance did exceed 5 feet, you would move the grade break and install the detectable warnings along the back of the curb, kind of like what we saw in the depressed corner images. This slide and the next one list a few locations where detectable warning surfaces are required. So we've already been talking about curb ramps and blended transitions, but some of the other locations where they're required include pedestrian refuge islands, at-grade rail crossings, so crossings of railroads, and boarding platforms. So that could be rail transit stops or transit stops that are above standard curb height, so above a 6-inch curb, which is commonly used on like bus rapid transit projects. They are also required at raised crosswalks, which we saw a photo of, shared use path crossings, and then specifically signalized driveways or driveways with yield or stop control. The next few slides have some examples of these specific cases. So here are detectable warning surfaces at a driveway with stop control. Detectable warning surfaces are also required for crossing separated bike lanes. So bikes are legally considered vehicles. So a bike lane is a vehicle lane. And so you'll have your detectable warning surfaces on both ends of that crossing. Here are a couple photos of detectable warning surfaces at shared use path crossings. So you can notice that the detectable warning spans the entire width of the ramp or the blended transition, even though it's a lot wider than 4 feet. Detectable warning surfaces are also used at pedestrian refuge medians. An important thing to note here is that there's a required separation between detectable warnings of 2 feet. So you'll have your 2-foot detectable warning, a 2-foot gap, and then another 2 feet of detectable warning. So a median has to be at least 6 feet for it to be a refuge and for you to install the detectable warnings. This next slide shows a median that is exactly 6 feet wide. And so in this case, to achieve that 2-foot separation between the warnings, they end up being installed at the face of curb rather than the back of curb. We also wanted to talk about bike ramps. This is a situation where previous guidance has recommended or suggested that you can install detectable warning surfaces at the top of the ramp, so that if someone walks there, they are then alerted that they're entering a vehicular space, which is the bike ramp. New guidance actually does not suggest the use of detectable warning surfaces here, and instead suggests the use of tactile directional indicators. So these guide pedestrians away from the ramp so that they don't actually get to the ramp to begin with. If you have not seen a tactile directional indicator, then you're in luck because I have one. So it looks like this, and it's got these like raised kind of long rectangular sections. And so people with vision disabilities can detect these, and they sometimes walk along them. So this is what would be used at a bicycle ramp. They're kind of more common in other countries, but they are increasing in popularity in the US. Yeah, and the yellow line shows where you would install it for this situation. You'd have to be careful not to direct the pedestrian into the sign. Here's another configuration of a bicycle ramp. And again, the tactile directional indicators direct people away from the ramp. And this is a photo from Hilliard, which I think is the first installation of tactile directional indicators in Central Ohio. But please, someone let me know if I'm wrong about that, because I've been spreading this rumor, if so. Are there questions about detectable warning surfaces?
Thank you so much, Miriam. I have actually sent you some internal questions that I'm hoping you will be able to answer while Jeremy is presenting on his next piece, or while, so we can help with the time constraints that we have.
Okay. I'll keep going then with this technical and feasibility section and look at those questions later.
Thank you.
So we've been alluding to this, but there are situations where you might not be able to fully 100% meet PROWAG. And when that happens, it's really important to document both the reasons why you're unable to meet it and what different designs you tried that didn't work out. PROWAG doesn't specify exactly how to document it, but there is an ODOT waiver that we'll talk about in a couple slides. It's also important to know that, and Jeremy said this, but if you can't meet some aspect of PROWAG, you still have to try your best to meet it. So it's not like you should just throw it away if you're not going to fully meet it. You should still try your best and to the maximum extent that you can to meet PROWAG. Here are some of the possible constraints that might prevent you from fully meeting PROWAG. It could be that the underlying terrain does not really lend itself to the slopes required in PROWAG. There could be underground structures that prevent you from meeting it, or adjacent developments. That's what we're showing in this picture. It's an example from Minnesota. You can see that the door of the building creates this constraint where the sidewalk has to be at that elevation right there. And so then because of how narrow the sidewalk is, the ramp ends up being really steep, steeper than the 8.3% in PROAG. Some other examples of constraints might include drainage or notable natural or historic features. The ability to meet or not meet PROAG is also tied to the scope of the project. So I'll share a couple examples that I think have been shared already, but if you would need to acquire right-of-way to make a curb ramp compliant, and the project's not scoped to acquire any right-of-way, then you won't be able to meet PROAG. But if you are acquiring right-of-way in other parts of the project, then you would need to consider or evaluate acquiring right-of-way to make the curb ramp compliant as well. Similarly, if you had to do some sort of utility adjustment or relocation to make a curb ramp compliant, but you're not scoped for any utility adjustment or work throughout the whole rest of the project, then you could do the waiver and say that you're not able to meet ADA. The ODOT curb ramp waiver form is online, so you can search for it pretty easily. It involves documenting the reasons that you're not able to make a curb ramp compliant, and then also kind of inputting some information about the dimensions of the curb ramp you're proposing. And then you can upload attachments to kind of support your argument and show what you tried and why that didn't work. So someone at ODOT will review those and then approve or deny the waiver. I think I'll hand it back to Jeremy.
Hey, Jeremy, real quick, for some reason we have lost sound from you.
Sorry.
There you go. You're back. Thank you.
Yeah, quick build curb extensions is something that PROWAG doesn't explicitly discuss, but actually the MUTCD does have some imagery of what we're talking about. And so it sort of relates to the two options that we have available to us to do a quick build curb extension or intersection daylighting. These go by multiple terms. One option is to leave the detectable warnings on an existing curb ramp that's back at the curb line. And that's sort of what image B, the bottom image, is showing, that you already had curb ramps. Those curb ramps were presumably compliant, and you're not going to adjust those. The challenge with doing that, though, and the example on the bottom right is a good example of why that's not a good idea, is that a pedestrian with a vision disability would be waiting on the right-hand side of that crossing back at the curb line, because that's where the detectable warnings are located. And so that's where they would be waiting to hear whether they get a gap in traffic. So the other option is to actually pull the detectable warning surfaces out to the edge of the travel lane. And while the red information in that top image is not from the MUTCD, that is a recommendation based on research that if you are going to do this, you should add trapezoidal delineators or parking stops or some sort of other densely spaced vertical elements, so that a pedestrian that proceeds down the curb ramp that does not have detectable warning surfaces on it has something reliably detectable to guide them out to those detectable warning surfaces. So this is an example of option one. There's a quick build curb extension. The curb ramp has a detectable warning surface. A pedestrian with a vision disability will not get the benefit of waiting out in that curb extension. They would inevitably wait back on the detectable warning surfaces themselves. Option two here is to do a quick build curb extension and to locate those detectable warning surfaces out at the edge of the flex post or quick curb. As I said, though, it would be preferable to then install some additional vertical element, though it's worth noting in this example, the use of the flex posts, that they do have a curb associated with them, so a pedestrian could inadvertently walk out into the street without detecting a vertical element. And I'll keep proceeding and assume that any questions that get asked will be assigned to me in the Q&A, correct, Jen?
That is correct, Jeremy. Thank you for the clarification.
All right, we'll jump into temporary curb ramps. And so these are ramps that may be assigned during construction in order to provide an accessible route for a pedestrian. So PROWAG states clearly that if you are providing an alternate pedestrian access route, that anywhere that it crosses a curb or crosses the curb line, that you need to provide a curb ramp or a blended transition. Now, if that was occurring at an intersection or where you are encouraging a crossing to occur, then those locations would also need to have the detectable warning surface to communicate that you are interfacing with the vehicular space. by comparison, the top image here would be that perhaps you are closing the sidewalk and you are diverting pedestrians into a channelized pathway along the curb line. Those instances would not have detectable warning surfaces. But all the slope and grade criteria still applies, the 1 to 12 maximum slopes, all the other design guidance associated with curb ramps applies to temporary curb ramps as well, including that they must be firm, stable, and slip resistant, etc. Sometimes these temporary ramps are built up, and that's what Miriam was saying before, that is an allowable style of curb ramp, but would be typical in a temporary installation to allow that grade change to occur. They also do tend to have some challenges associated with them. So if you just surface apply the asphalt or leveling area, that tends to warp and sort of go out of compliance. So you do typically need to do a little bit of excavation, like what's shown on the image on the left, to kind of lock that into place and prevent that, that movement of the material. There are also modular systems that can be deployed. I've seen the ones on the left deployed quite effectively to navigate these instances. Both of these are failing though, because these are street crossing locations and they do not include the detectable warning surfaces. So that is a requirement of PROWAG and something that would need to be provided as part of these designs. And this is a good example of what I was saying before. This is a temporary installation using a modular system, but it's diverting pedestrians from the closed sidewalk into a channelized area where they are protected from adjacent motor vehicle traffic. So installations like this do not require those detectable warning surfaces. Next, we'll jump into push buttons, and by push buttons, I'm referring to accessible push buttons at signalized intersections. I see a lot of challenges when it comes to push buttons installed in the real world, particularly those that have been installed long ago and prior to the adoption of PROWAG or prior to the adoption of the use of accessible push button systems. So this is a common installation, and there are lots of things wrong with it. It's too high off the ground. You can't actually reach it from the accessible route. There's no indication of which button activates which direction. It would be incredibly difficult for a pedestrian with a vision disability to even find it. The push button type doesn't include the tactile information and other information that's required by PROWAG, and there's no audible information, which again is required by PROWAG. I also see situations like this where the push button is there, but if I were a person with a vision disability, I'm probably not going to find it. It's back there on that pole, and so even if I did find it, it would complicate my ability to cross the street if I'm a person with a vision disability, because I have to find it and then cross from that location at the back of the sidewalk all the way to the crossing location. And so that's why PROWAG is very explicit about the placement of push button locations. It's also worth noting that there are some differences between what's cited in PROWAG and what's cited in the MUTCD. So the base graphic of this image is from the MUTCD, calling out that the location of the push button needs to be within 10 feet of the curb ramp itself. PROWAG actually says that's 5 feet, not 10. The MUTCD says that you need 4 feet of space between the placement of the push button and the adjacent flare. That's not actually aligning with what we see in PROWAG. PROWAG simply says that you need to be able to reach the push button, and so really it would be more like 30 inches of separation. So comparing this previous graphic that shows areas A, B, and C that are allowable per the MUTCD, PROWAG essentially only allows placement in proximity to area A and a portion of area B. I found this interesting image from Polera that does a great job of illustrating the requirements for push button locations and comparing and contrasting what the MUTCD says versus the approved version of PROWAG. So just a good resource of understanding what each document says. And in general, you should go with the more conservative of these values if you have questions. And this idea about push buttons needing to be accessible and having a accessible route between the flare and the button itself really runs counter to the graphics that we see included in PROAG, and that sort of tucking the push button at the corner of the landing at the top of the ramp isn't centering that push button on the landing areas, but it is an accessible area as either a front or side reach requirement. So this is just illustrating you have that landing, and tucking that push button in the corner both helps to keep it out of the way and maximize the usable space of the sidewalk and the curb ramp itself, providing it in a place that's easily found and is still accessible. So what I'm talking about here is that rather than needing a 4-foot by 4-foot area, you really just need a 30-inch by 48-inch area that is clear and unobstructed adjacent to that push button so that it can be pressed. Then when somebody were to press that, they need to navigate to the top of the ramp in order to then navigate the crossing. So stepping through the different requirements, per PROAG, a push button needs to be located within 5 feet of the curb ramp or the furthest crosswalk line. So whichever one of those is further, you're measuring 5 feet from that location, and your push button needs to fall within that range. In terms of proximity to the curb line, it needs to be within 1.5 to 10 feet of the curb line itself, or edge of pavement or shoulder if a curb is not present. The push button itself needs to be oriented to align with the orientation of the crosswalk, and there needs to include a tactile arrow that is also aligning with that direction of travel, providing some tactile cues to a person with vision disabilities to understand the orientation of the crossing and the direction that that push button will activate. And then there's clear criteria on the mounting height of this, that from a vertical reach perspective, the push button needs to be between 34 and 48 inches. The 34-inch height is tied to if a person were using a side reach criteria to reach that. And the push button needs to be within 10 inches of the place where the person is pushing the button from, so from the accessible route. And this image is a great illustration of some of the installation considerations that we need to be thinking about in order to meet that criteria. So you can see that the signal foundation, or the push button foundation, was installed integral with the curb on the back of the sidewalk to ensure that that 10-inch maximum reach criteria would be met. Had that been placed with the foundation fully behind that curb, inevitably that button wouldn't have been able to be accessed, and you would have needed an extension arm to allow that to be placed. And then there's the criteria that push buttons need to be at least 10 feet away from each other, and if that's technically infeasible, we need to include additional information when somebody presses that button. So additional audible information communicating what crossing that button has activated. So it would tell you when you press it, wait here to cross whatever street at this intersecting location. And then when the walk indication comes on, the wording says what road you are crossing as part of the activation of that particular push button. We already had our break, so we're going to continue to move along. I did see there were some questions assigned to me, and I'll address those now as I turn it over to Miriam.
Yeah, so now we'll talk pretty briefly about the life cycle of a curb ramp. So this is sort of specific to ODOT projects, but the life cycle is shown on this next slide. So it starts with operations, then moves into planning, engineering, and construction. And we'll go through each of those stages in detail in the following slides. Yeah, so starting with operations, ODOT operations staff do basically an inspection of curb ramps within 30 to 90 days of installation. And then they upload that information into an online inventory of right-of-way assets, which includes curb ramps. You might be wondering why this is the first step, because it seems like it should be the last step, inspection after construction. But it's because that online inventory is used by planners then to figure out the initial stages of a project. So on the next slide is the planning portion. So the ODOT planning office uses that inventory and the data that was collected by the operations team. And with that, they figure out if there are existing ADA assets, such as curb ramps. Are those curb ramps compliant with ADA? And will curb ramp improvement be a part of the planned project? So if it's not, then they can add the waiver form that we talked about to that online inventory. But if ramp improvement will be part of a project, then that information is used for the project development plan, or the PDP. So after that, it moves on to engineering. The engineer will determine if it's feasible and practicable to comply with ADA for each of the curb ramps on the project. And so if it is, then design can kind of continue as usual. For ODOT projects, the designer adds the curb ramp asset to the inventory with a proposed status. Then they go through the phases of design up until bidding. If the engineer determines that it's not feasible, then that's to comply with ADA for the curb ramps. Then that's when they would notify the district's project manager and then complete that ADA waiver form. The waiver form then gets approved or denied. And if it's approved, then the curb ramp is still entered into the inventory with that proposed status, but the waiver is also entered into the inventory. And then again, design kind of continues as usual, moving through the phases of the plans and then eventually to bidding. So then the next step is construction. It's still possible that during the construction phase, we might find out that it actually isn't possible to fully comply with ADA. It's best if that's caught during design, but there could be some sort of unforeseen circumstance that prevents ADA compliance once a project is under construction. So at that point, then you would submit the waiver, and again, it would be approved or denied. But if that doesn't happen and it is possible to comply with ADA, then the project will be constructed. And after that, in the little online inventory, the status of the curb ramps will change from proposed to active. And then finally, after construction, is inspection. So we're back at the beginning of the life cycle. And these are just a couple photos that show inspection. So when curb ramps are inspected, they're measured at multiple locations. These photos show a landing being measured. So you would get the slope of the landing at the back and at the front. And then you would also turn the level and get the slope parallel to the ramp. And this is pretty typical that you would measure a curb ramp. Each component gets measured in multiple places. So for the ramp itself, for example, if you were measuring the running slope, you'd put the level at the left side, in the middle, and then at the right side. And you can maybe not follow the link exactly, but you can search up the curb ramp measuring guide, and you'll find that on the ODOT website if you want to know more. Okay, we've reached a very fun portion of the webinar where everyone gets to test their knowledge about whether or not you can tell if something is ADA compliant. I don't know that we can have people unmute, so I think you just have to think about the answer in your head. Okay, so this ramp was not compliant. There's no detectable warning surface. It's a single diagonal ramp, so not compliant for new construction. And the flares look like they might be too steep. Is this one accessible? I think this one might have been maybe easy. You can tell that there's no ramps for the crosswalk that is kind of going towards the back of the photo. And then also the push button is blocked by the trash cans. And then for the ramp that's going off towards the right corner, there's no detectable warning and there are also no flares. Okay, so for this one, it is accessible. So you can see that the detectable warnings are placed at the back of the curb. And it's hard to tell, but there is a push button on the pole, and that's positioned correctly as well. Is this one accessible? Yes. So you'll notice that this is a situation where it's a directional ramp on the radius section. So the detectable warnings are placed at the back of the curb. And you can tell that the grade break is like right above the detectable warning surface. Also in this picture, the roadway slope was changed to provide a compliant crosswalk slope. So you can kind of tell that the roadway is like going up and flattens a bit for the crosswalk section. Is this one accessible? No. The detectable warning surfaces do not span the entire width of each of the shared use path approaches. There was that, if you remember the detectable warning section, there is that allowance from PROWAG that if a concrete border is needed to properly install the detectable warning surface, you can get 2 inches on each side. These appear to be more than 2 inches, so they don't span the entire width. And then it's hard to tell, but I feel like they might be placed too far back and would be more beneficial if they were closer to the crosswalk. Is this one accessible? If you said no in your head, then you're correct. The detectable warning surface is not 2 feet deep for the whole width of it. And then the area on the left is flush, so it's same elevation as the street, but there's no guidance to tell someone that they would be entering the street right there. So you could potentially make that into a blended transition by adding the detectable warning surface, or if it's not supposed to be a crossing, then you could separate the sidewalk from the roadway and put up the no crossing sign. Hopefully that was enough time to think about it. So this one, the kind of near side curb ramp that we see is accessible. But if you look towards the background of the image, there's no receiving curb ramp. So that part is not accessible. There should be a companion curb ramp on the other side of this crossing. I feel like this next one is easy. This one is not PROWAG compliant because of these large gaps in between the detectable warning surfaces. So it should have been installed as like one continuous detectable warning.
I'll note that you're also not allowed to use green colored pavement inside a shared use path unless the bikes and pedestrians have their own separate space.
So this example is really similar to one that Jeremy just shared, where the foundation is kind of in line with the curb to make sure that the 10-inch reach is met. So yes, this is accessible. Is this one accessible? Hard to tell exactly, but maybe not. So the push button, it may or may not be accessible at that location. It's hard to tell in the photo. Following the pedestrian crosswalk, that median refuge, it looks like the detectable warnings might be under 4 feet wide. And then the bicycle ramp is not really necessary, and putting the detectable warning surfaces at the top of the ramp is not really in line with current guidance. Is this one accessible? No. So I feel like you can get this one without necessarily doing the curb ramp training if you know cross slope requirements of PROWAG. So it looks like the cross slope is definitely too steep, and the flares are in the pedestrian access route, so it's not compliant. So this one is compliant. You'll notice that the curb ramp doesn't have flares because it's next to non-walkable surfaces. So you can kind of see the landscaping at the bottom. And the trash can near the top middle of the image makes that surface also non-walkable. So this one is accessible as a shared use path Yeah, so the bike lane and the sidewalk here function as a shared use path. And so the detectable warning surface then spans the entire width of that. Technically, the markings are not MUTCD compliant, but the ramp or blended transition itself is compliant.
That one was a trick.
We didn't cover MUTCD markings in this training. I know everyone will get this one. So this is not compliant with PROWAG because of the flares in the pedestrian access route. Hard to tell if the push button location is compliant. This is very similar to the situation Jeremy talked about where the ramp itself might be compliant, but needs a landing behind it for the entire design to be fully compliant. So this is compliant. I know we can't really measure 10 inches in this photo, but it appears that the extension arm is being used to bring it within the 10-inch reach requirement.
Yeah, the only questionable thing why it's yes question mark is whether the push button can actually be reached from the landing, and the landing in the foreground isn't really visible, but probably is compliant.
So here, no, it's not accessible because the signal equipment is too low, so it's protruding, and then also blocking access to the push button. We've seen a very similar example. So this is compliant and it matches what's shown in the MUTCD, where you can move the detectable warning surfaces to the edge of the quick build curb extension. It's not compliant because we're not achieving that 2 feet of separation between detectable warning surfaces. This is the last one, so make sure your guesses are good. No, it's not accessible because the ramps and detectable warning surfaces should connect to the aisles, and instead they kind of direct you into that parking stop.
Miriam, do you want to take these and kind of move quickly through them?
Yeah. Okay, so we want to talk a bit about the design process and some of the coordination that needs to happen. There's certain aspects of roadway design that could then make the curb ramp design difficult. So it's important that people working on these are working together and collaborating to kind of avoid issues further on. Some of the aspects of roadway design that specifically could complicate curb ramp design include the roadway running slopes, steep crowns and gutters that could result in the curb ramp and then the gutter being too great of a difference in grade. The push button placement, surface and underground utilities, those might need to be moved to make the curb ramps compliant. The scope of work, So mill and overlay versus a full reconstruction. Non-compliant sidewalks at the tie-in points can make curb ramp construction a bit more complicated. And then adjacent buildings and access, like we saw in that example with the building on the corner in Minnesota. I'll now run typically when you're designing, you'll start with identifying what your limitations are. So these are the constraints that will kind of guide your design. It could be right-of-way or utilities or topography or existing developments and buildings. Any of those could be like the points that you're trying to tie into that kind of anchor your design. In our first example, we have, it's part of a Safe Routes to School project, so we're really just installing crosswalk and curb ramps. We're not resurfacing, so we're trying to limit our changes to the curb line. And because right-of-way is not a part of the scope, we're trying to stay within the existing right-of-way, just about a foot off the back of the walk. In this example, the first thing we tried was a perpendicular curb ramp. So that's the tier 1 curb ramp and the preferred design. But once we put in this 5 by 5 foot landing at the existing walk elevation, the ramp ended up being steeper than 7.69%. So we tried something else. It's clear from that first iteration that we needed to lower the landing. So that's what we did, is lower the landing a bit. And then we now have these 2 panels tying the landing to the existing walk. So this is a combination curb ramp because those 2 panels tying the existing walk to the landing, those are ramping down steeper than 5%. And then we have the landing in the middle and then the ramp. So in this design, all of the ramp slopes were compliant. They were less than 7.69%. One issue that we ran into was that the existing walk had cross slopes that were not compliant. So what ended up happening is that those two approach ones, we decided to do another panel on each side. So this gives us a greater area to transition the cross slope from something that's not compliant to something that is. And then also by replacing 2 panels on each side, we were able to kind of flatten the grades a bit more. So now those approach slopes are less than 5%, and we're actually back to the perpendicular curb ramp design. It's no longer a combination curb ramp. And then the only issue with this was that the flow line was really flat. So we were concerned about ponding. One thing that we considered but ended up not doing is on the next slide, we considered modifying the profile of the gutter to make it a bit steeper through the ramp. But that would result in making the gutter shallower away from the ramp. So we ultimately did not decide to do that. But that was kind of the end result on that project, was a perpendicular ramp with about 10 feet of replacing the walk on each side of the landing. And then one more project really quickly. The scope here was to replace the walk shown in the solid blue line on the right side of the right image. There were a lot of corners that did not have any existing ramps. So the preferred design on the next slide was doing 2 ramps with grass in between them. So then there's minimizing the width of the flares required. This was the preferred solution, and it also involved reducing the radius so that there's actually more space on the corner to work with. We were not able to do this for every intersection. So we also had an alternative design on the next slide, where there are two ramps that are just closer together. This is still preferred over like a fan or a depressed corner because it provides more directional information to people walking and helps them align themselves with the crossing better. Okay. In conclusion, thank you all so much for listening to our webinar. We have a few key takeaways. The important things to note are that we're all pedestrians at some point in our journey, and so all of us benefit from this accessible infrastructure. Even though curb ramps, maybe you don't absolutely need them right now, that will probably change at some point in your life. And so they really do help everyone. And last takeaway, directional ramps are preferred because they reduce out of direction travel for people, and they help orient people with vision disabilities to the direction of the crossing. Kind of one more takeaway is that even though it can be overwhelming to design a curb ramp because of all of the requirements, there are a lot of resources to help you. So on this next slide, we've highlighted some of them, including PROWAG, and then guidance from the Ohio Department of Transportation. So the Multimodal Design Guide, Standard Drawing BP 7.1, and the policy on resurfacing that we talked about at the beginning. So thank you again so much to the Ohio Department of Transportation for organizing this webinar. And if you have additional questions or need more guidance on curb ramps and ADA, you can reach out to Dawn Fisher in the department, the Office of Roadway Engineering.
Thank
Thank
you
you.
so much, Miriam. So I'm impressed. We got to this. We met our time constraint. Well done. Thank you to everyone who stuck with us and asked the great questions. We do have about 3 questions that are outstanding. Nicholas, Paul, and Bradley, someone will get with you to answer your questions. We do have your contact information in order to do that, so we didn't forget about you. So one note that I want to mention is that you may have noticed when you were looking at our or at the handout that some of the links that are connected with ODOT might be broken due to ODOT's website upgrade that just happened on Thursday evening. So we are going to be getting an updated version of that handout, and we'll send that out when we send out the links to the recording as well, so that you will have that at your disposal. So I would just like to say that on behalf of the LTAP Center and everyone here at ODOT, a massive thank you to Miriam and Jeremy for sharing their time, knowledge, and expertise with us this morning. Just a quick reminder as we sign off, please keep an eye on your inbox over the next 10 days for the webinar recording and the presentation slides updated. And for those of you who were with us for the full session, your certificates will be emailed to you within 5 business days. The last favor before you log out, as soon as the webinar closes, a super short 4-question survey will pop up in your browser. It truly takes less than a minute, and your feedback helps us keep making these sessions better and better for all of you. So thank you so much for your time and engagement today. I hope you found it valuable, and I hope you have a wonderful rest of your day. Take care, everyone. Bye-bye.